My name is Oki. I work with Fairfield Group and Vo Software. Fairfield Group is the commercial partner of Vo Software. We do training and consulting as well as supporting people evaluating the software. And Vo Software is the maker of quantitative risk analysis tools and one of the premier creators of these sorts of tools. And today we wanted to focus on ModelRisk, which is probably the most long-standing tool created by Vo Software. It's an Excel plugin for Monte Carlo simulation. It's an incredibly powerful tool, but it's also just an incredibly powerful application in general. So Monte Carlo simulation, whether you're doing it with coding yourself or you're using other tools, it is a fantastic practice for modeling uncertainty and getting a better grip. So what we wanted to do in today's session is do things slightly differently, where we had an idea of doing a webinar where we go through a cost estimate with a risk register. I've got Martin joining as well. Right, yeah, so we wanted to do this webinar slightly differently because Monte Carlo, if you're familiar with it, you'll know it has so many wide applications. It's used in insurance market for actuaries to price up premiums, to understand risk. It's used in cost estimation and government contracts and also construction to understand the cost of a project, take into consideration different uncertainty. It's used in agriculture for understanding how fertile, the next crop is going to be. And it's used in engineering for things like Six Sigma analysis, which supports with doing things in a more efficient way. So, this is why it's such a joy working in the space, because every day and every week we get to talk to people doing completely different things. And it's just very inspiring and very interesting. So we thought in this webinar, rather than go through one use case, we're going to have a bunch of mystery doors. So several different mystery doors, and I'll be relying on the people in this call to help us choose which door to go through. And then we'll spend and behind each mystery door, there is a Monte Carlo model, and we'll spend probably about 10 to 15 minutes going through the model and then giving you also, 5-10 minutes asking questions and maybe getting some clarification around things, and then move on to the next mystery door. So that here, so and because we both came from working at this company, we understand it quite well, understand why people enjoy it, and it's a really good tool. One of the main reasons we've seen people switch to ModelRisk, which is what we're working on a lot as well. About 70% of our new customers are at-risk users. Crystal Ball somewhat as well, although Crystal Ball is not as popular as it used to be. It's not really that supported anymore. So one of the reasons we see a lot of switching is ModelRisk is about 50% less expensive than something like at-risk. You're able to convert your models, but still keep your ribbon looking the same, just as Gustavo showed at the beginning. You'll be able to gain some capabilities, and QRA is our DNA. So when it comes to Vo Software, QRA is what we do in quantitative risk analysis, and that's all we do. It's all we think about. We only want to serve this community and this group of people. And I think you can tell probably Gustavo and I are quite geeky about Monte Carlo, which is why we found our home with Vo Software. If you want to just visualize that pricing comparison, I mentioned 50%, but actually seeing it maybe on paper might be a bit easier. Where if we're looking at a 1 year, one user, subscription, for example, if we're looking at at-risk Pro or at-risk Industrial, for multi-years, there's no discount. There's a built-in 7% increase. And for volumes, there's also no discount. Unless you're really, really good at negotiating, you might be able to get something. And then when it comes to ModelRisk, $1,500 a year. For multi-years, of course, there's a discount. For volume, of course, there's a discount. And that really exacerbates when you go into multiple users over multiple years, because with a 7% increase and no volume discount, what you're looking at with that Risk Pro, for example, which is the basic version of the software, you're looking at nearly $30,000, whereas with ModelRisk, you're looking at $14,000. And that is despite the fact that really the way the tools behave is rather similar. And the things that you can achieve with both of them is also rather similar, except that obviously we have prioritized certain things, they have prioritized certain other things. So there will be some differences in the tools. But in general, ModelRisk is really built out the most capable Monte Carlo simulator that I've come across. In terms of switching, you see we're already 40% through the presentation. I promise it's really quick. In terms of switching, incredibly simple, just because the nomenclature is very similar. Risk normal turns into Vo's normal. Risk output turns into Vo's output. this triangle turns into Vos triangle. Kind of compare it to switching from, I don't know, a Google phone to an iPhone to a Samsung Android. There might be a day or half a day of moving your new apps and your pictures and everything over, but there's usually tools for that if it's in the cloud or something, and it's really easy and quick to do. Very similar in this case, and because the nomenclature is so similar, when you hit that conversion button, if you do have an at-risk model open or a crystal ball model open, about 95% of the functions will just directly convert, and you get a report that tells you which ones did and didn't, and you can go and ahead and manually change the ones that didn't, or we can do that for you. So you can send us those models and we can convert everything for you. In terms of gaining capabilities compared to some of the other tools you might see, that results viewer that you saw is unique to ModelRisk. What Gustavo was showing, where you can look at the inputs and select different ones and select different outputs, that is completely unique to ModelRisk. And again, where I mentioned those valued certain things, one of them being reporting. We know that reporting is incredibly important. It's how you drive those conversations, and it's how you visualize the results that you get. So we've invested a lot into building a really powerful results viewer. And QRA is our DNA, and I just thought I'd share this picture of, again, very geeky picture of all the distributions available. Now, most people will only use these ones down here, which are the most common distributions. But just knowing that you have access to all of these here, that if you do want to get more advanced, more detailed, it's there for you. It's just waiting. And this especially comes in handy when you're fitting distributions, because you've got so many different distributions that you can compare your data sets against. So that was it. That's the whole presentation. As I said, I'll be brief. Personally, not a huge fan of presentations, which is why when I do them, they're very, very quick. And this slide here is what we call social proof. Essentially, it lets you know if you want to get up and dance in the park, you're not the only one. There's other people dancing as well. So if you like the music, feel free to dance. These are some of the people we've had the pleasure of working with since with ModelRisk and supporting with ModelRisk. So we've got the mystery doors set up, and as I mentioned, we're relying on you to help us decide which mystery doors to go after. So if I go to the next slide, you see we have 4 doors ready to be chosen, and you let us know which door we will go through, behind which will be a Monte Carlo model. So we've got mystery door number 1, number 2, number 3, and number 4. If you just put into the chat any number between 1 and 4, and then I'll let Gustavo let me know which number comes up the most. I'll give you maybe 30 seconds to do that, and then we'll go for that particular door. So just choose your favorite color. I like green. I'll probably go for number 2.
Now you have to do the count. So
30, 29, 28, 27, 26, 20, 15.
I think it's mostly on 1, I guess.
10, 5, 4, 3, 2, 1. All right, presto. Gustavo, which number are we going to go through first?
I think it's number 1. I think because we have like 5 of them. So let me share my screen here.
Numero 1.
And yes, let me share
what
my
we have
screen
is
here.
a risk register.
Okay, great. So let me share my screen. Open number 1. Go. Okay, can you see my screen? Yes. So. Okay, great. So let me share with you what this risk register is. So you remember that in the quantitative risk analysis world, right? You have uncertainty in every model, right? And you have risk registers, right? Where you have these events. And this could be there's a lot of noise. I'm not sure from who. Just 1 second. So what we have, as I was saying, was uncertainty here and the risk events here, right? And the idea is that this first model, we're going to cover this portion of it, right? the total, let's say, cost of the model or time of the model. In this case, we're going to do cost, and we're going to explore how to set up a risk register here in ModelRisk. So if you know this is the first time that you see ModelRisk is an add-on to Excel, right? That runs on top of Excel. That means that all the models that you have in Excel, you can easily transform them to ModelRisk, right? If you happen to have models that you have in at-risk, you can also convert the models, and Aoki's gonna maybe show this at the end, and you can convert this from at-risk, bulk. Even you can change the setup of the ribbon, make it to look like at-risk if you like, right? So there's a lot of things that you can do here. For example, you can change the language, and you can change, you see, you have even an at-risk style there. Right? Now, let's go to the typical quantitative risk analysis framework. As I was explaining before, right? I have 5 risks here. Each one of these risks can be multiple or single, meaning that single occur once over the lifetime or over the project of the analysis horizon, or multiple can occur more than one time. And depending on that, you see that you can have, for example, a Poisson distribution here for the multiple, or you have a Bernoulli distribution here for the single. You see, that's one, meaning that here in this column E, you will have the number of times the risk occurred. You see, every time I press F9, this is going to change. Now, the impact that we have here, and this could be millions, or it could be pounds, or dollars, or euros, right? This is a per distribution that comes from these 3 different minimum, most like, and maximum, like this, you see? So what we do here, and we do what we call an aggregate, and I'm not going to go deep into this, which is basically when I say I have 3 problems with community in this potential scenario, I will generate 3 PERT distributions, right, internally, and I'm going to sum them together, right? These 3, and then this is the number that you see here, right? And this is, I'm going to do that with every one of them. So I'm going to run one, and this is what we call pre-mitigation risk calculation. So I run one simulation with 1,000 iterations, right, like this. And what I will get, right, we'll see here, I will get a results, well, I call the results viewer, which is here. I show you 1 second. So I don't want to have a lot of things to show here. Here we go. Okay. So I have only one simulation. Right? So I'm just going to show the total pre, right? That's the risk register. Let me show you here. The total pre. This is the curve that I'm looking at right now. See? So this total that we had here, now we had it in here. Right? Now, in terms of the results viewer, what you can see here, it's a really nice tool where you can have these types of graphics, or you can have, for example, you can change it to a typical histogram like this, you see? So, and you can move these markers, you can put your own markers here on top. So it's a tool that lets you do a lot of things that I will show in a minute. Like, for example, I generate a tornado chart. For example, I have my tornado chart here, which says that the main risk is the problems with the community, and it could take from 406 to 860 million, let's say, because of that. So I have to take care of that, and I can change the tornado chart here to more to different charts, like, for example, a correlation tornado chart, which is simpler, but lets you see which are the potential underlying relationships. Or, for example, you can do proportional contribution to the spread, which is basically breaking it down in percentages. Right? So in percentages, so you can see which one of the variables are the ones that affect the most to it. Right? I can, of course, copy and paste these graphics. I can generate more graphics, and I will generate that in a second. Right? So let's say that I have, remember, my results here, my first results, which were this history, remember, between 0 and 694, right? These were my first results. And now what I can do, I will open up the model, and let's say that I invest some money, say $350,000. I invested in these potential controls, right? This is the cost, this is hard cost, right? I need to write some checks. And here what I did, I changed some of the probabilities and some of the impacts because of adding this controls. Why? Because this is the typical as is and to be, right? So the as is the pre-mitigation, the to be is the post-mitigation. And what's going to happen is that I'm going to have the exact same model that I have here, but of course with different parameters. Okay? Now you see here that my total is going to be called total residual post, right? Before it was total residual free. So I already run the simulation, so that means that all the variables that I have here are already simulated. And I'm going to check the result. And for example, what I can do is I can say, I'll compare what happens with my total inherent versus my total residual. You see? So the residual is going to be here in blue, while the inherent is going to be in green. So what happens is that I can show here what was the effect of my mitigation controls. Right? If I like, I can change it to cumulative. Sometimes it's easier to understand. And you see here what is the difference, right? From P80 that was 1 million, see my P80 is now 300. So that what happened is that it was able to decrease my exposure by investing this money, right? So I paid like $350,000 here, and I decreased it from 1 million to 300, right? So that means that it was a good thing. Now, if you want to generate results like this, for example, you can set up right, something like that, right? This is my random total, right? The one that comes pre-mitigation, the post-mitigation. This one includes the total controls. And you can generate something that it's called percentiles like this, you see? Gaussian percentile. So it means that after the simulation, this is the P80 that I was showing you in this on screen, right? This is the same P80 that I had before. So this P80 was 1 million versus 685. And the mean was 694 versus 552. Okay? So I did just a very simple calculation of contingency, which is the subtraction of P80 minus the mean. So you can get this mean with Gaussian mean, meaning that you don't need to every time go to the graphic, fetch the result, copy that maybe by hand or doing Control C, but you can put it down here. And this contingency, you see that now goes from 325 to 133. So then you will have to decide, right? If investing 350,000, your contingency lowers almost to the third of it, if it's worth it or not. So this risk register, if you pick the right door, right, we can add it. Remember, I'm going to do like a circular closing here, so I will give it to you again. Okay, remember that we were here, right? So there's another model, which is the cost estimation model, that will be here, right? So that's a little bit of what you can do with a risk register. So back to you, Aki.
Cool. Wonderful. Thank you so much, Gustavo. And I don't think you gave an introduction, but Gustavo, I like to introduce Gustavo because he's always very humble about himself. I can brag a bit about you because I really like you and he's really great. So Gustavo was the director of consulting for Palisade, which makes up risk, which is a competitor tool to model risk for over a decade, where he supported people with all various types of problems and models, which is why he's got, any model for any situation loaded up. We usually do a lot of our meetings together, and no matter what someone might throw at us and say, oh yeah, we're doing this kind of really complex payout insurance thing, Gustavo will have something in the bag, and he's just a joy to work with, and put together the presentation that I'm using with the Mystery Doors. So yeah, that's Gustavo. Thank you so much for that. Any questions on the risk register, on how you model that with Monte Carlo? I know a lot of people are used to seeing maybe qualitative risk registers, and some of the major work that we do is helping people make those quantitative, so that you can make more informed decisions based on them. Any questions on that or any clarifications? Just use the raise hand. Oh, there we go. Michael Boykus.
Yes, good afternoon. I just have a question in terms of the model that you use for the risk register. How did you determine the post-mitigation item or the impact? Was it model or was it estimated?
Oh I'm so sorry. It was very hard to listen. I'm not sure.
The question was in the post-mitigation values that you had, right? You had pre-mitigation values and post-mitigation values. How did you determine what the post-mitigation values would be? Where did those assumptions come from?
Yeah, normally what happens is that when you talk to all these providers or these external parties, or there's maybe some other teams in your company, you have to estimate with them. You have to have an exercise of estimation on how these are going to change, right? Because if you say that you have an average of 2 issues with the community, what you will have to is to translate this into a quantitative estimation, right? It should be an estimation, because of course this is your best shot, right? If you hire, and I've been there, if you hire a community problems expert, right? I mean, sometimes they have really good, I don't know, negotiation skills, and they can maybe bring this to 0, or maybe things are going to go exactly the same way. So sometimes you just have to talk to these people, or maybe when you have more quantitative things or controls like an exchange rate exposure or an environmental impact approval and things like that, normally that's better. But when you have soft, let's say, soft event that you want to prevent, yeah, that's going to be a little bit more difficult, right? It's expert judgment. Yeah, expert judgment combined with maybe I would say a track record, and hopefully you have some benchmark.
Exactly. It's all about the communication. I mean, that's one of the ways that I oftentimes describe Monte Carlo simulation and what it produces. It's a communication tool. It just allows people to talk about their assumptions in a more scientific way to then drive more informed decision making. So if you were speaking with your community manager and they were to give you the estimates of how much they could improve things, if you gave them, here it is, I think 40, right? You give them maybe 40 grand it is, and they tell you, well, I can bring these incidents down from 2 times to 1 time, and the impact will be reduced as well. That's the kind of conversations you can then have and then remodel, and then talk about, right, cost us 40, and actually after we simulated the results that you told us you'd get, it seems well worth doing. So if you can hit these results, this is a great investment, we can go forward with it. So it's really a communication tool, and yeah, you can talk with those subject matter experts, or you can use track record historical data to do that assessment as well. Any more questions? Thank you so much for that question. That was really good.
So if not, let me show you the complement to this model. So everybody has the complete picture. And let me see here. And this is the complement to the model, because the next one was number 1, which is good. So let me show you here. Right? And please don't take this into consideration yet, because you need to run a simulation to go with this, right? So as I said at the beginning, remember that I wanted to show you this framework, right? This is the cost uncertainty in this case, and these are the risk events. So we started from the end here for what maybe the risk management team would do, right? Which is to estimate the risks, right? In terms of, in this case, money, right? We're talking about money here. Now, what happens with the cost? And this is the uncertainty, right? This is normally the natural oscillation, right? Variables because of the uncertain nature. So what we did, we generated this this budget, and with this budget, we generated again a deterministic budget, which was 4.3 million, and then we added some uncertainty ranges, right? We started here, and then we added some uncertainty ranges, right, for the min and max, and generated these uncertainties, right? So I'm going to build this from scratch. And then the complete model, what it does, it takes into consideration the complete summation of this, right, which is the same. You see, this is the same, this is the same. And for the pre-mitigation, it sums up the pre-mitigation impact. Remember this 599, which was here. This is the 599. This one was here. And for the post-mitigation, it sums up the 16.3, which is the impact, plus the 357. So basically this, right? 357 and 16, right? We can provide later the models if you like. Right? And what you will be able to do, you'll be able to do 3 scenarios, right? One is for the uncertainty only, no risks. The second one is the uncertainty pre-mitigation risk and uncertainty post-mitigation risks, right? Like this. So what I'm going to do, I'm going to run a simulation again. Right? So let me open ModelRisk here. I start here. I will run, let's say, 1,000 iterations. Right? And this is going to generate like a progress bar. And here, what I will do is I will open the results. Remember that you have the results. I'm not going to go into the risk register. You see that each one of these are each one of this, right? So it's basically every sheet that you have is going to be represented there. So I don't want to see the risk register. I want to see the costs. Remember, because I have these three outputs. So I open the cost. You see, I have my total baseline cost, which is here. Okay, and I can change that to a histogram too. This is the baseline. Then I have my pre-mitigation. Remember, this was the product, the pre-mitigation risks. You see, it's basically the same graphic that I generated. Remember, now this is the impact of the risks. And I have my total post-mitigation that if everything goes right, it should be a little bit between these two, right? Which is here, you see? Why? And of course, I will change it to the cumulative because I wanted to add controls, right? You can see here you have a lot of options for markers if you like. For example, I don't want to have my PAT there right? Because it's a lot of things on my 4.3. So you see now it's much cleaner, and then you can move around your percentiles if you like this, right? So you can compare all of that, right? For example, if I do PAT, so if I can go there to PAT and compare the PAT of the three, you see 4.7 before 5.3, 5.6, etc. Right? What are things that I can do? I can do a tornado chart, but now my tornado chart is going to be the pre-mitigation one, remember? And then I can change it to this conditional mean, which is the one that I like. And what I can do in the tornado chart is that I can say, I just want to do the tornado chart with my cost items, right? Because I'm talking with the budget manager, and the budget manager needs to know which are the main budget items that he has to take care of. Then when I do a plenary, I will say, well, now I want to see everything, right? Both the risk management team and the budgeting team. So I can click there, and you see that sometimes you have, for example, problem with community here, resource scarcity. Then you have the implementation of the pipeline or the final derivative, right? Which are costs that we have here, right? Like this. So you have the capability of disaggregating the two. And this is something that you don't have in any other Monte Carlo simulation tool, which is the ability to, in this case, select which variables you want to affect without having to, wire everything in the model. That normally takes a lot of time. If you want to see, for example, I can generate what we call box plot chart like this. And then I want to do the baseline costs versus the pre-mitigation cost. You see, this is with the effect of the risks. And I want to compare it with the total post-mitigation like this. See? So as I said before, you have your baseline cost, then you go to your pre-mitigation, and then you say, well, with the controls, I can bring it here. Right? So this is the cycle that you have for the risks. And let me see what else. What else you can do? You can generate a listing of all the different samples. You have the 1,000 samples here. You can copy that and put it into Excel. You can generate reports if you like here. I will generate one simple report for the outputs, and let's say cumulative ascending with statistics. So I will create a report, and that report's created on the fly, right? Like this. And if you like, you can take a look here, right? The three curves that I had before, plus the statistics for all this, the variables that I had. So these are a couple of things, a couple of tricks that you have there to make you more productive. So I will go back to you, Oki, in case there are questions. Otherwise, you will let me know which one you want me to show.
Yes, exactly. Thank you so much for elaborating on that and showing the full picture there of a complete risk register attached to a cost item, cost model. Any questions on that, on what Gustavo just showed now, kind of extending on what we showed before?
What is contained under the uncertainty double?
No, I'm really sorry, Michael. Your volume is very low. I'm not sure, okay, if you got it, but maybe it's my headset. But it was something about the uncertainty, Michael. Maybe you can write it down. I will be happy to answer.
I could. Yeah, I didn't hear that very well.
No, me neither. Sure. Oh, what is in the uncertainty formula? Oh yeah, thank you, Michael. In the uncertainty formula, what you have are two things, right? One thing, yeah, it's a good question. One thing that you have there is the pair distribution. So this is a simple pair distribution with these three parameters, right? And one good practice, because you cannot do it, right? And the model will run anyways, but your tornado charts are not going to be as nice, is that you have to name all the variables like this. So I added a Vos input, right, which is the same, like if you're familiar with that risk, it's going to be your risk name. This is the same, this is called Vos input. It's simpler because you don't have to do a parenthesis and all that. It's simpler because it's part of the formula. And what you do is basically you say, what's the name of the variable, right? So the number of what you have the name of the variable, this is the name that will appear in the tornado chart. You see, your tornado chart is going to call this sign because you have the Vos input. That's going to be this sign. Yeah. Thank you, Michael. Excellent. Good question. Yeah.
Brilliant. Okay, and I think now it's time to go to the second mystery door. So let me just get that part up on my screen here. There we go, desktop number 3. I thought it'd be smooth if I had multiple desktops set up and I just switch between desktops, but it's not. But there we go. So
to go with 4.
Back to the mystery doors. Go with 4. So we've got distribution fit and time series fit. So we're going to be doing some fitting. So the purpose of fitting distributions or time series is if you have historical data. So like that question Michael asked before, what do you use to make your assumptions? In some cases, it will be subject matter expert opinion. In some cases, it will be you've got a backlog of information, or if you're trying to understand, for example, how interest rates will move, you've obviously got many years of historical data that you can go on to understand how interest rates move. I wasn't finished, Gustavo.
No, please go ahead. I was
started sharing screen. It's fine.
Yeah, don't worry.
No, that's fine. Yeah, that's it. You fit data. If you have historical data, you can fit distributions to it or fit the time series to it to understand how it might behave. If it's a distribution fit, you understand how the numbers behave, and if it's a time series fit, you want to extrapolate into the future that particular set of data. And with ModelRisk, you can do it for multiple sets of data at once for a time series. So you could, even if you have 2 sets of data or 3 or 4 in a row, and you wanted to understand how they correlated and going to move forward in tandem, you can actually model that out too. So that's one of the really cool, unique features about ModelRisk. But yeah, I'll let you get into it now, Gustavo.
Sorry, okay, yeah,
no problem.
Not a problem. So what I did here, this is what we did is we generated some commodity prices prediction, right? And you see here that as Oki was saying, we did it with a distribution feed approach and with a time series approach. I'll be brief, and as I showed before how ModelRisk works and the main capabilities in terms of operations, so I'm going to jump right into it. What we have here are quarterly price from last 22 years, right? For this commodity. And what we wanted to do a prediction of, you see, the next, as you can see, 1, 2, 3, 4, 5, the next 6 quarters, right? What we generated is a distribution fit, not for the price, but for the variation of the price. Because normally when you do distribution fitting with prices, right, you will have to take a look to the variation, which is simple. I mean, it's just the variation of the past quarter versus the current quarter, right? And I generated a distribution for that. So the mechanics for the distribution fitting is you just take historical information. And this could be applied to all, right? You can have productivity, you can have, I don't know, steel prices, you can have here a number of people that are going to be in a factory, you can have anything, right, to do the distribution fitting. Right? So you go to fit, you go to distribution fit, and what this is going to do, this is going to take the observations, and the observations are going to be here. It's basically the real data. Now what you will do, you will say, well, give me all distributions that I can compare with my observations, and with that you do this add button, you see that some of them are in grayed out. They grayed out like this. So you don't have to do, you cannot apply that. This is something that the software does automatically, and you have this little arrow button that's going to take all the valid ones and generate that. So basically, it's going to compare all the distributions to the one that I have. And what it does, it gives me the best option based on I'm not going to get to statistics here on a maximum likelihood in an optimization process that runs in the back. And then you can see visually, you can compare which are the approach that I have. Some are really good, like for example, this normal distribution is not that good. That's why it's not first on the list. And for example, you have like this student distribution, which is awful. If you like, you can overlay a few like this, see, with colors. So you can overlay and do a visual inspection of that. So let's say that our HS distribution is the best one that we want to see, right? What we're going to do, we can, first of all, we can generate a report, a complete report of the statistical process that was followed. We have also some PP plots and QQ plots, right? And again, this is, if you do distribution fitting, you will have this, right? And then what you can do, you can say, I want this distribution to be put into my worksheet, right? Linked to my data or not linked to my data. If it's linked to my data, that means that, for example, let's say that you have like something like a price feed or a commodities prices feed that comes every day or every hour to your Excel sheet, that's going to be changed automatically. So you don't have to rewire and do this process all over again. Or I can generate a not linked to data distribution like this. For example, I put it there, close it, and here's the distribution that I was able to get, right? This is it. And this is the distribution of my variation. You see, it has my, automatically generates the parameters. You can have boundary options if you like. You can shift the distribution left or right, right, in the axis. Right? And what I did, I generated this distribution here. You see, it's the same HS distribution. I generated and copied that down. And I just multiplied the deterministic forecast that we got from, let's say, from a benchmark study from your studies team or some economical team that you have in your company. And we just going to generate this prediction. You see here, this is the prediction that we're going to generate. The green volatile, you see, volatile prediction. The ones in yellow are the ones that we have here static in blue. And what we're going to do, we're going to run a simulation. And once we run the simulation, you will see what happens. We're going to generate 3 percentiles, which are here. See, and I'm going to show you first in Excel, and then I will show you here. See, and here what you have are again, the percentiles. For this prediction, I want to have the 10th percentile, 50th percentile, and 90th percentile, close compared to the reference. So the reference is here in blue, you see, here in blue. And what I have here is this funnel, right? That it's in dot lines, that it's going to show me where between my P10 and P90 is going to be my prediction, like this. You see? So I'm building a prediction over time. And you can do that directly in Excel. If you like, you can go to the results, as I was doing before, right? And say, well, what is it that I want to see? Because now I have another model, which is my distribution fitting. My distribution fitting has a forecast, and I can take a look to the distribution, to the histogram, for example, for 2027, 2029, like this, right? Or if you like, I can generate what I call a trend graphic, where I see the trend, which is basically the same that I have here, right? So I can generate that as well. So this is the first one. The second approach that we have is, let's use not a distribution fitting for the variation, but a time series on top of the price. So when you do a time series, and this is going to be a little bit more advanced. A time series is a complete equation, right? It's an equation of a model that's going to be on top of the price. And for that, that simplifies things. And instead of going variable by variable, like for example, I did here for the variation, you can go there and do a complete time series analysis for the price directly into the model like this. You see here, fitting univariate time series. As Oki said, if you have, for example, a basket of, I don't know, currencies, or if you have a lot of different time series or variations, right? You can do time series multivariate, and then you see how correlated they are, or you can do that with distribution fitting as well. You have two ways, right? So I can generate that, and this is going to generate time series, you see? So the time series are, as I said before, these are different equations that you have, let's say, prepared. Right? And I'm going to select all of them. It's going to take a minute, and this is going to try to fit all these time series to my time series, like this. You see? So this is the historical information, the one in red here, and the prediction is going to be the one in blue. So I can choose, again, as I did before, but you see that before it was just one point in time. In this case, it's a complete forecast that you can make with the time series, right? So as before, if you have a time series that is lower in the ranking, is going to be not as a good fit as the one that you have very high in the ranking, like this, right? And then you can generate two and see how it's going to behave using limits. And you can do the exact same thing. I just have to fit the location of it, right? If you want to have like a more advanced time series demo, please let Oki know, and we'll be happy to do it, because otherwise sometimes this is something that people don't normally do, right? So you can select the output range, for example. I can select that here, and this is going to generate automatically, right? When I insert to the worksheet, it's going to generate automatically the prediction, right? And this is what's happening in the back, right? Here, I have the prediction directly. And as I run the model, what I wanted to show is that you see that you have one way of doing this with a distribution fitting, and one way to do this with a time series. So there are two ways to generate this type of model, which is really cool. I mean, I really like it because it's so simple. And you see that the preparation of the data is not difficult, right? That's going to be about it. Okay, I'm not sure if somebody has any question. Of course, if you happen to have historical information, definitely try it out. Normally 25, 30 samples are good enough to give you some good approximation of a distribution, in case you're wondering. Please, okay.
No, thank you so much. That's brilliant. This is this is the model that we usually bring up in our demonstrations when we have calls with people. And it's a really good one. I really like this one, and because you've got the little graphic there pointed in as well with the cone to kind of illustrate the ranges that you can get. And it's that simple of setting up a time series, and it's that alternative to subject matter expertise. You can also have, if you have historical data, if it's the kind of thing where it's publicly available or internally available, you can point the software at your data, so you don't have to even get subject matter experts involved, or they can support you and just maybe adding extra dimensionality to your data or your information. So any questions on time series? No. Okay, in that case then, we can go over to our final mystery door.
Let's go to the mystery door, yes.
Exactly. I didn't think we get through all the mystery doors. I thought maybe we'll do a couple, but here we go. We've got the insurance premium, Model 3. And this model simulates how insurance companies replicate claims and reassurance levels. It includes the number of people protected, their premium payments, deductibles, and total gross margin. It includes scenarios using or not using reinsurance. So insurance is probably one of the largest cohorts of people using Monte Carlo simulation. The actuaries have been using Monte Carlo in some form or another since probably the 17th century is when they first started doing this in a non-computerized way. And then it got computerized in about the 50s and 60s. And then tools like these came out in like the 80s and 90s. So it's still a relatively cutting edge thing to be doing Monte Carlo computerized on a PC. But yeah, the insurance people have been doing that for a very long time. And they are really well versed when it comes to, especially the actuaries, really well versed when it comes to the world of modeling. So we've got an insurance premium model as well, which if you're in the insurance business, you probably will have seen this. This will be very familiar, and might be curious to see how it's done in insurance. And if you're on the risk management side, you'll learn a little bit about how insurance companies are pricing up your premiums, which is very good to know. So, Gustavo, thank you very much for letting me introduce that. I'll let you get into the actual model.
You go. Let me do that. So let me show you here. And I'm going to do a quick intro on how the model works so you understand what it has. It's a very small model, which is what we really like. So what we have here, we have a number of events, which it's a Poisson distribution that we have here in the C columns, right? And this is the number of events that happen, right? Number of claims. Let's say 84 claims. So we have here all the claims. So what I did is I generated a list of all the claims. Right? I said, well, we have 84. That's why you see you have 0 here. So 84. For each one of the claims, you have a total, right? This total comes from a log normal distribution that we set up here with the severity and standard deviation. See here. Each claim has a total, remember. Now, the moment that you have a claim, let's say 5,000 pounds, let's say here, you have to have a deductible, right? Which is here, which is 1,100, right? You see here? So you have this deductible here. So sometimes when you have a claim that it's, let's say, almost 4,000 pounds, but the insurance company needs to pay.
Michael put in the chat that he can't see the screen.
Oh, really? Let me share it again. Yeah, I will share it.
Exactly.
Yeah, not a problem.
And then Michael, let us know if that comes through.
Okay, good.
So, I can see the screen. Can you see it now, Michael?
So what I'm going to do, screen is visible. Thank you, Nicola. Much appreciated.
Screen is visible.
So, okay. So what you have here is this deductible, and the deductible that the 1,100, yeah, that's subtracted, right? And that's what the company needs to pay, right? Like this. So how does it work? The math is really simple, at least in this model, right? Of course, we know that it's much more complicated than this sometimes, right? Depending on the types of policy and the limits and all the different limits that you will have. So let's say that, for example, you have this premium income, which is just a multiplication of what the company pays per person and how many people you have, right? So it's basically P times Q, which is here, right? I have 2,000 people paying 50 pounds each, like this, right? But I have to pay all of this, right? Let's say this month, I have to pay all of this. So my gross income, it's, well, in this case, in this scenario, less than 1,000. If I run it like this, sometimes you have a really good result, and sometimes it's not as good. Sometimes you see that it could be negative. Let me see if I can make it negative at some point. This is all random, so of course I have no control whatsoever about it. So here you go. For example, I have my income 138 and my compensation payments are a lot, so I lose in this month, in this particular scenario, 20,000. So what I can do, I can run this. I'm not going to use insurance. You see here. So I will say, I'm just going to run one simulation, and I'll explain this in a second. You see here, I have to run two. So let me run the first simulation on. So I want to run the simulation. And I'm good. So I don't have any reinsurance. And what I have is my net margin, like this. Right? So let me show you here without the reinsurance. Here we go. So you see that the distribution goes to the other end, right? Because this is how much am I going to make, which is, right? Everything that is going to be above 0, which is this. This is how much you're going to make, right? This is positive for the insurance company. And in red, this is bad, right? I mean, not bad, but this is what the insurance company should pay. But remember, for the net margin, you don't have enough money. Right? So that means that you have the premiums times the number of people, it was negative, so you have all this big tail. So what's the idea of reinsurance? The idea of reinsurance is that you basically sell this tail to the reinsurance company, you get a smaller tail here, but you have to pay, and here it is, you have to pay a reinsurance premium, meaning that basically the reinsurance company is going to get paid 40,000, but you will have a deductible. So how does it work? For example, here, let me show you in a minute. For example, here, you have, let me make it here. So I have to, my income is going to be 147,000. I have to pay 88,000. So my gross margin is going to be 58. But I have to pay to the insurance company 40,000. But paying that to the reinsurance company is going to cut my tail. So basically, I'm going to make 18 million or 18,000. Right? Sometimes I don't make as much money. And the idea of the model is to compare how good is going to be this condition. So imagine that you have a reinsurance company. I'm not sure if we have insurance people here. I think that these conditions are the ones that you're negotiating, right? So with this model, this is very small model, you can compare what happens if you don't have reinsurance and you have reinsurance. Of course, it depends on the type of policy, it depends on the regulations of the country that you always have to have reinsurance. So maybe the conditions are going to differ here. And what you can do, and what I really like about ModelRisk, is that you see that you have a different dimension here. You remember that you have the outputs and the inputs. Now you have the number of simulations. So I'm running what we call sim table here. You see, you have what we call a VOS sim table, saying that this is going to be 0 or 1, basically, right? 0 or 1. And here we have an if condition. If we have reinsurance, it's going to be 40,000. If we have reinsurance, it's going to be the compensation recovery. So we have different logic there. And if it's a 0, and this is going to be, every time that you run a simulation, this is going to be 0 and 1. Right? That means that the two scenarios will going to be run. So meaning that with no reinsurance, you have this, and with reinsurance, you will see how the shape, you see, how the shape changes. And my tail is cut starting from here. You see? This is the tail that the reinsurance bought. Reinsurance. Right? This is what I sold to them, right? For, of course, I got 40,000. I got to pay 40,000, but I got all these 100,000 in exposure that I am not paying. You see here, in 100,000, I'm not paying for that, which is a good thing, right? But you see what's the effect of that? The effect of that is that the distribution that I used to have before in green, I will pay in blue. It's simpler. Now it's smaller, you see? So this is all the margin that I'm giving away because I sold the tail, right? It's basically,
this might be where it's a good idea to switch to a line rather than bars to show the difference.
Exactly. Yeah. And I was just going to do that. Then here you can see that. See? So sometimes it depends on the person. It depends how you like to model. So the good thing is that you will have the ability to pick and choose which one you want to show here as well. You see, you have these little tabs. So you can change that like this. See? And this one was, for example, you have a minimum of minus 800 with a maximum 168, but now you will have less maximum, smaller maximum, 125, but your minimum is going to be capped at minus 71, right? So that's the effect of the reinsurance. And of course, you can do the same things. You can do tornado charts, you can do Pareto charts analysis. So you have the same framework that you had before, right? But now in a totally different industry. Remember that we were in the risk register industry, which is pure risk management. Then we went to, I don't know, construction or project management. Then we went to, I don't know, maybe financial industry. And now here we are talking about insurance. So you see that's the versatility of Monte Carlo simulation. So with 5 minutes to go, I will go back to you, Oki, in case you want to do some closing words.
Oh, that was brilliant. Thank you so much, Gustavo. A really, really nice insurance model there. And yeah, as I mentioned, curious for people who are currently doing this in insurance to see how it works with ModelRisk. You see, it's very intuitive, quite easy to do, definitely easier than Python. And if you are currently someone who is maybe in risk management, nice to see how your risk transfers get priced up essentially. So any questions on this insurance model?